So on Tuesday, we were talking about factoring out GCFs. And for both of these in numbers 1 and 2, your GCFs were monomials, right? So there was one term that they had in common. What was the GCF for number 1? 1 x. Good. They both have x's. And then you pick the lowest exponent, which in this case would be x to the first. And then what do you get inside your parentheses? 4x, because you took 1x away, minus 3. Good. And there's no x here because your x was pulled out right there. What was your GCF for number 2? 5y. So then what does that leave you with inside the parentheses? 2y. Minus 1. Good, because 5y goes into 5y one time. So you still need that 1 there, because if you don't put that 1 there, it's like that whole term disappeared. So that term is still there. There's just one of them. Okay? How could you check to see if these were right? Distribute it back in and make sure that they're correct. Okay, but remember that when we're factoring, we're working backwards. And so again, even though this answer looks kind of longer and more expanded than the question to begin with, so you might think like, do I need to go back and distribute it back in? You don't want to do that because the whole goal of factoring is to essentially lower your exponents so that you can solve the problem. Because right here in number 2, we have a y to the third, but we've broken it down in our answer, and now we only have a y squared. So that's going to allow us to factor it completely, and we'll end up with basically no exponents so that we can solve these problems for y, rather than just being able to say like, oh, well, I can't simplify those at all because they're not like terms, so I'll just leave it as it is. Okay, so remember, factoring means even if they look a little more complicated, we're actually simplifying them because our exponents are getting smaller. All right, so we're going to take like a little detour today, and we're going to talk about factoring by grouping, which has a lot to do with what we were talking about at the end of class on Tuesday, where we had common binomial GCFs. So we're going to talk today about how to break down polynomials using grouping. All right, so for example, think back to Tuesday. We said sometimes a GCF is a binomial. In this case, what is our GCF? What is our GCF? No. Think back to the second half of class on Tuesday.
Oh,
so we
no,
said,
your GCF is x minus 3.
yeah, the GCF is x minus 3. How come?
Because it's repeated.
Yeah, both of them are being multiplied by x minus 3. So the GCF here would be x minus 3. So then when we factor it out, that's what goes on the outside of the parentheses. It's still in its own set of parentheses because it's a binomial, so you got to hold it together. And then what's in the next set of parentheses? 7 minus 2x. All right, so again, this is what we did in the last half of class on Tuesday. And we said, here's our common factor, which looks a little bit different than the ones that you just did in the rewind, because the common factor here is a binomial. It doesn't make it any, it's not wrong, it's just a binomial GCF. So your GCF goes in the first set, and then you essentially put all your leftovers right here. And the leftovers are the stuff that's outside, because that's the stuff that's being multiplied by that GCF. So that's what we did at the end of class on Tuesday. What we're going to talk about now is how to get your problems so that they look like this if they don't look like this to begin with. All right? So take a look at this right here. First of all, let's name this. What degree is this to? Third degree, which makes it a cubic polynomial, because it has 4 terms, right? So it has a cubic polynomial. So what we're going to talk about is the method of putting together common binomial factors and sort things into groups. So essentially what we're going to do is take a look at this. Is there a greatest common factor in all of these? Is there anything that goes into all 4 of the terms?
No, 3 doesn't go into 20.
Yeah, 3 doesn't go into 20.
No, just 1.
Just 1? So you'd look at that and think like, oh, that must be prime, right? Because only 1 can go into all of them. But what we're going to do is factor by grouping, which means we're going to take a look at this as if it's 2 separate problems. So let's just look at, I'm going to overline this one. Let's just look at the red part. Is there a GCF of the red part? 3z squared. 3z squared. Because 3 goes into 12 and 9. They both have a z, and what's the littlest exponent? 2. So I'm going to say my GCF is 3z squared. And if I factor that out, what am I left with here? 4z, good. Not to the second because we had 3. We took out 2, so how many do we have left? Just 1. So 3z or 4z minus, how many times is 3 going to 9? 3. And then z squared is z squared, so then do I have any z's left? No. Okay, so there's my red part. Look at my blue part. Do those have anything in common? 5. 5 goes into both of them. So if I take out a 5, do I want to take a positive or negative 5? Probably positive, so let's do a plus 5. What am I left with here? 4. Do you notice anything? What's the same? Yeah, so now all of a sudden we have a GCF because they have the same binomial GCF. They're multiplied by the same binomial. So now how can I write this out? What's my GCF? Perfect. And then what are my leftovers? Perfect. Okay, so that's factoring it. So now all of a sudden we took this complicated 4-term one and we lowered our exponents. So now we only have a squared and a z to the 1 instead of having z to the 3rd. Okay, this is called factoring by grouping. So you can't take a GCF out of all of it because there isn't one, but you can separate it into pairs and take a GCF out of those. Now, would this have worked if we hadn't gotten 4z minus 3 and 4z minus 3? Like if it's not the same, then there's no point in really doing it. Okay, the whole goal of this is that we find a common binomial factor. So this is called factoring by grouping. And when we finish this whole unit, the thing that I want you to remember is you don't do this a lot, but you do it most often when there's 4 terms. Okay, so whenever there's 4 terms, you want to look to group them. Because we're going to focus mostly for like the last half of the unit on quadratic trinomials. That's what we're going to factor most of the time. But when we do grouping, most often it's when you have 4 terms. Okay, so let's take a look at another one. All right. So again, we have 4 terms here. And is there a GCF of all of them? Is there anything that goes into all of them? No? Nothing goes into all of them. So what could I do? Make it into 2 problems. What pairs do you want to use? 9 and 18. And then, so this one will be our green pair. And then x and 2 will be our red pair. So let's do our green pair first. What's a GCF in that green pair? 9 x squared. Good, because this one has 3 and this one has 2, so we pick this 2. All right, so if I factor that out, what am I left with here? 1x to the 1 power. So do I need either of those ones? No, so I can just call that what? X. All right, so x plus, how many times is that going to that? Twice. Any x's left? Nope. All right, what's my GCF in my red terms? Do those have anything in common? So what's a GCF if they don't have anything in common? 1. So I can take out a 1. And that leaves me with what? X plus 2. Do these match? Yes. So is that a common GCF? Absolutely. So then what would that be? Perfect. Because those are my leftovers. So that's factoring by grouping. Yes.
So whenever we have something like under the red,
Mm-hmm.
so do we just like put 1?
Yeah. Yeah, because when I look at this, I think, oh, well, that's already the same as that, but I need that 1 there because I need something down here. So I can take out a 1 because 1 is always a factor, but usually you don't have to take it out because it doesn't really help. Like it wouldn't help to take a 1 out of all of them because you need to get these to match. But yeah, you need something as like a, it's basically just like a placeholder. You need a placeholder factor there. Okay, I want you guys to try this one. I want you to do this one. And your exit ticket, do those 3 problems at the board. Okay, so do those 3 problems at your boards, and then I'll move this one to the next slide so you can see them all. Yeah, so do the practice problem and the exit ticket at your board. So you should be trying 3 of them up there.